Okay, so in this slide video, we're going to do advanced analysis, and so this is where we're going to use some more complex advanced functions and tools in Excel to look at some deeper analysis we can do of our data. And again, of course, as would be expected, we're still in the analysis phase of the problem-solving cycle. And so in this slide video, we're going to talk about goal seek and solver, as well as pivot tables. But specifically for goal seek and solver, there's a couple add-ins we have to enable. And so I have this slide here just so you have, after the fact, a quick reference for the steps, but I'll go in detail through these 5 steps when we get to Excel at the end of this video. So the first additional function we're going to look at is goal seek, this functional capability called goal seek. And a scenario we might use this is a scenario where maybe I decide that we're going to cancel the rest of the assignments and projects in this class except for the midterm project. So everything you've done up till the midterm is all you're going to get graded on in this course. And the question would be, what score do you need to get on that midterm project to earn an A in the course? Taking into account the grades you've gotten up to today, and then what's the grade you need to get on the midterm project? You've probably asked the same question, but in reference to a final exam. What do you need to get on the final exam to pass the course, right? And so we can sit down with a calculator and paper and pencil and do this, and I'm sure we've all done that, but goal seek is actually a very helpful tool in Excel that will do this calculation for us. It'll go through all the combinations of different scores or grades we could get on a final exam or a final project, say, or a term project, and spit out a number that we need to get in order to get a certain maybe percentage grade in a course, right? And so goal seek determines a value, right, that you need to enter into a single input cell to produce a result that you want from a formula cell. So a couple things are going on here. First of all, we have a formula, right? Maybe in our scenario we have, our grades plus our midterm grade divided by how many points in the course will give us a percentage, right? So we have that formula, and this goal seek will allow us to have Excel figure out what value for the midterm score there needs to be so that the answer to the formula is, say, 93% or greater. Okay, and so a key part of this is that we need a formula already set up in Excel, okay, and that the goal seek, so goal seek only relates to one variable, okay, it can only manipulate one variable at a time. So if we have a function and an equation and we want to change one variable until we get a certain result, goal seek then is our tool of choice that we can use to do that. And that's located in the Data tab under What If Analysis and then Goal Seek. And we'll demo this in a few minutes. But just the takeaway here at the outset is that Goal Seek allows us to manipulate a value in a single cell until a result of a formula cell reaches a certain value, and we determine what that value is that we want. So now a couple key things to just make note of. Excel may not be able to find every solution to every equation we want it to. A solution may not exist. We may be asking it to do something that's mathematically impossible. And of course, goal seek will let us know that. If the solution does exist, but it's not giving us the answer or an answer, right? So if we're getting this status box indicating that Excel cannot calculate a result, and we are sure that there is an actual theoretical solution to that, we need to double check our logic, right? Or double check our formula, okay? And so to make sure that we've inputted the right formula and we've set up goal seek properly. If we're not getting an answer that we think we should get, we might have to go back and look at how we've set up the parameters. Okay, so we'll demo this now in Excel. So I'm going to go over to Excel. You should have this ppt11 example file that you can open up. You can download that from Blackboard. And basically what this has is a couple different tabs with some different examples of goal seek and some of the other functions we're going to talk about today. We're going to hit enable editing. So the first is our example we talked about in the slides, okay? So we have different assignments, okay, including the milestones for the different midterm points. And then we have scores and possible scores, okay, possible scores and then what we actually got. And so we can see that there's 580 total points possible for these items, and of course we have yet to get a midterm milestone 4 score. So our question at hand is, what does this score need to be so that we get at least an A? Okay, so our 54% is less than an A, right? If I get 250 and 97%, I'm solid A, right? Nothing to worry about. But what is that score? What's the minimum score that I need to get to have a 93%? And I could sit here and I could do this, and get lucky there, right? I could do this for a little bit of time. It's not take too long, but I might want to just say, what's the bare minimum? And sometimes you actually want to minimize and come out to the exact number and not as large of a guesstimate as, maybe 225 is. So the way we do this, the way we allow Excel to go through and run through all the combinations of values into this cell until we get this cell here, which is an equation. Okay, we just see that it's our score divided by our possible score, percentage, right? And so what value do we need in cell C7 so that cell C10 equals 93% or greater? Okay, what's the minimum value? So we would go to data and what if and goal seek. Okay, now it's important to note that I have my equation in C10 already set up. Okay, that needs to be done off the bat. Okay, and so we want to say set cell. Okay, so the cell that we want to set, this formula cell, C10, we want that result to be 0.93, okay, by changing this cell, C7. Okay, so we want to identify what value should C7 be so that C10 is exactly 93%. Once we have that, we'll hit go ahead, and it will calculate and to tell us that actually 227.25 is the score we need to get exactly 93%. Okay, and so Excel has done that legwork, and we can kind of see it a little more dynamically. Excel has done that legwork for us so that we don't have to go through all the combinations. But remember, it works on a single cell. Okay, we're changing one cell at a time. Okay, and so if we have multiple cells and a combination of variables, we can't use goal seek. Okay, but if we have a single variable we want to modulate, then we can use goal seek to find a specific result to an equation, okay, based on changing one variable. Okay, so, and there's other scenarios we could use this in. We have this scenario that we've talked about previously in the course, I believe. So we have 80,000 gallon reservoir. How many inches of water will cover 1 acre of land? We've previously calculated with 80,000 gallons, we can convert that to, based on our equation here, we can convert that to almost 3 inches of water per acre. Okay, what about this? How many gallons do we need to cover 1 acre with 5 inches? Okay, so we want the result here to be 5 by changing the gallons. So we could sit here, and this may take a little bit longer amount of time, but not with goal seek. We can just do that very quickly. We can say set E4 to 5 inches, okay, by changing gallons, okay. So that runs through and we have 135 and change, right? So I could sit here fairly quickly and come up with a bunch of different values of gallons on the reservoir to get different irrigation levels, right, or inches of water per acre. And so this is really where goal seek comes into play when I'm trying to maybe do multiple calculations, and I don't want to spend the time to do this guess and check. I just want to let Excel run through that and give me one answer in just a few milliseconds. Okay, there's other examples we could go through. Torque. We want a specific torque on a wrench based on how many pounds, and we could go through that. And maybe we, need to understand how much torque to torque a bolt to. We won't go through this one, but it's the same process. Okay, we're changing this formula based on the value that we put into this cell. Okay, and we're letting Excel change this value until the answer equals the value that we have determined it to be. Okay, let's hop back to the slides here. So the next functionality we're going to look at in Excel is solver. Solver has an ability to do multiple variables. So let's say the scenario is we have a farm, it's a 1,500 acre farm, and we want to produce corn and we want to produce soybeans, and of course it costs us these amounts per acre to plant corn and soybean, and that's of course to run the equipment, to buy the seeds, to irrigate, to all that, fertilize, right? And we want to then go sell that, and then we're going to have a projected sale price of these values for corn and soybean respectively. And of course the yield is 175 for corn, 60 for soybean. And our question is, what is the best combination of planting to yield the largest profit? So we have an option of planting corn and soybean in some different percentages. What's the largest acreage of each we should plant to maximize our profit? Okay, so now we're doing a little bit more than just goal seek. We're actually modifying two different variables. How many acres of soybean and corn we plant. And we're looking at maximizing something. Okay, so solver can find optimal value based on multiple variable inputs. Okay, and we'll do this through our data and our solver tabs. We need to enable this functionality, and so we'll go through that. But really the key point is we have multiple variables, okay, and we're optimizing. And we can either optimize to a max, okay, we can optimize to a minimum, okay, or we can optimize to a certain point, okay. And so we have different models that we may have of, maximizing, minimizing, or going to a certain point, okay. And it will calculate the values of the X and the Y that we need to get to that maximum value or that minimum value or that certain value, okay. So we'll jump back to Excel and we're going to look at this crop example. Okay, so I have the scenario here. I've asked the question, what's the combination to yield the highest or largest profit? But we have some constraints we need to be considering. We need to consider that we have to plant at least 400 acres of corn, okay, and at least 200 acres of soybean. All right, so we have some constraints there we have to live by. Of course, our farm is 1,500 acres. We don't have any more than 1,500 acres. Now, what I've done here, and what I like to do with Solver, is set up a nice, clear, organized table of my inputs. Okay, cost to produce per bushel, yield in bushels per acre, acres planted, bushels harvested, sale price per bushel, and then my costs and my sale price, right? So these are my total costs, my sale price, and then my profit for corn, which is just a combination of the sale price minus my costs, right? Pay off my debts. And then of course, soybeans the same, and I have my sum total here in yellow, which is a combination of corn and soybean, okay? And so I've set these equations all up already, okay? I've set up my costs being cost per bushel, how many bushels did I harvest for both, right? How many bushels did I harvest based on how many bushels I planted, or acres I planted, per the yield in bushels per acre. Okay, so all we're really doing here is unit conversion. Okay, we're doing some fractional multiplication to get our different results. And of course, my sale price is how much I harvest per how much per bushel I can get when I go to sell. So I have all that set up. Okay, now if we go to data and we go to we should see over here a solver functionality. Okay, if we don't see that, we need to go and enable that add-in. So we go to File, Options, and all these steps are on that one slide. Add-ins, and then Analysis Toolpack. And you'll probably see that in inactive applications. So we click that, we hit Go. Okay, it's important you hit the Go, then you can actually select Solver Add-in. Okay, and hit OK. And that'll open up that add-in, and we'll see this solver add-in. And so now we're ready to set up this solver capability based on having all this information already inputted and ready to go with an actual function and equation set up. I have an equation here to calculate total acres planted, right? Because I don't want my total acres planted to exceed 1,500. Okay, right now I've planted 1 acre of each, which I know is not correct because I have to have at least 400 and 200 of soybean or corn and soybean. But let's just start it out as 1 and 1, okay? Because we know this number is going to change. So we know these numbers are going to change. But we're going to change both of these together to get this value total to be maximized. Okay, so let's select that, C23. Let's go up to Solver. And here we have a dialog window with a couple different options. Okay, set objective. Okay, what's our objective? Our objective is to maximize C23. Okay, and we can hit max. We could min, we could set a value to a certain value, but we want to max, right? What are the cells that we want to change? Okay, we want to change E16 and 17. Okay, corn and soybean acres. Now, a note that the cells that you want to change, Excel wants to see them next to each other. Okay, it doesn't want to see any spaces in between. So put those cells next to each other, then you can just select that range of cells. Okay, so it's going to change those. Now, the constraints, though, we have to define some constraints. Okay, and those are the constraints we have here. And so we need to add a constraint. We need to say the first constraint is corn has to be at least 400 acres. Okay, so greater than or equal to 400. Okay, and so the cell we want to be greater than or equal to 400 is the corn cell. Okay, E16. We want to add one more. We want to say E17 needs to be at least, okay, so greater than, equal to 200. Okay, and there's one more constraint we need to add. We need to add a constraint of no more than 1,500. Okay, so add one more and say that this cell here, which is a function, the sum of both crop planted acres, right? And we say this has to equal 1,500. We want to plant across all of our land. Hit OK. So now we have these 3 constraints, right? We can double check those. 400 for corn, 200 for soybeans, 1,500 total. Now we have an option of solving. And there's a couple different methods. We're going to stick with the simplex method, okay? That's a linear solving model that it uses. And we're going to click Solve. So Excel found a solution, okay? We want to keep the solution because, of course, down here you can see that we have almost a little bit above $500,000. But we want to report, right? We want to report our answer, okay? And I'll show you why in a second here. So click on Answer, Reports, and hit OK. And what this does is it shows it here, of course, but more importantly, it gives another tab that it generates with our answer, and it shows us how it solved it. You know, it has Excel 16, it's the worksheet that we had, the date, okay, the results, the type of solving engine it used, how it did that. But then really is what I want to see from your results are these 3 tables, okay? It has the objective, okay? We wanted to maximize this cell. We started out with $600 and change, and we ended with a little over $500,000, okay? The variables that we had, soybean and corn, okay? We started with 1 acre each, ended with 13 and 200. And of course the constraints, okay? So this list of 3 tables shows us the before and it shows us the after And it also shows us the variables and the constraints that we used. So this proves to me that we ran our solution with the solver, okay, because I can see a small value up to a large value and what you were doing and how it would run. Okay, so these three tables is what I would like to see as your solution, and I really want to see some variation between the original and the final to prove to me that you actually did run it and it did something changed. So that's the basics of solver. Okay, you can run through a lot of different scenarios, but you have to have your functions and your equations already set up. Okay, and they all have to be dynamic. Okay, if we were to come in here and change this to back to 1, and we were to say the total I have to be at 1500, I would hard code in 1500, basically saying it's not an equation anymore, it's just a number. And I go to run solver again, and this is where a lot of students trip up here. They have all their constraints and their variables that they want to change and objectives all set properly, and you're looking at E18 to make sure that's equal to 1500, and you go to solve, and it says the objective cell values do not converge. What that means is somewhere in your worksheet, in some function, it couldn't actually modify a function, and so there's somewhere where you have hard coded a number where you should have had a dynamic function or equation. Okay, so of course that's what we did here. We said let's just hard code that to 1500. We would need to change that back to the sum of our two acreages, okay, because that will then dynamically change based on our changing amounts of acreages here. So the first time I added E18, which is too many. Okay, so we need to keep those dynamic functions or equations as part of our worksheet. Okay, if we don't have it dynamic, Excel will never be able to get that dynamic changing to be able to solve for a solution. So that's solver. Okay, those are the ways of setting it up, some of the biggest gotcha to be aware of, and how to show or answer. So going back to our PowerPoint slide here, now we want to look at pivot tables or pivot charts. And so let's say we have a large table of data. It has these columns. Okay, it has some tasks, individuals, categories, phases, positions, hours, and costs. So maybe you can think of this as a whole bunch of information about how much time different people spend on different tasks during different phases of a project and how much it costs, right? And maybe we want to find quickly, okay, keyword quickly, how many hours each individual spent in each phase of a project. Okay, so we want to go and we want to look at our individual, how many hours they spent per phase. Okay, so individuals per phase and how many hours they spent. And so if we look at a pivot chart or pivot table, we're allowed to and able to really quickly pull that information out of a very large table of data, and we'll show that in a second here. But basically, pivot tables and pivot charts take a big data set, okay, and allow us to generate custom tables based on various column combinations, and we get to choose what those combinations of columns are. And we'll find this under the Insert Pivot Tables or Insert Pivot Chart. So let's jump back over there, and we'll finish up our video here with this. This is just another example, a manufacturing example of the solver. But looking at the pivot table, here's our data. And I have a data table. Okay, so this is formatted as a table, and it's got a bunch of lines here. And I have dates, I have tasks, individuals, hours, categories, phases, all those different things with rates and costs at the end. So what I'm trying to do is I'm trying to look at, I'll jump back here, trying to look at how many hours each individual spent during each phase of the project. Okay, and so I can look at a pivot chart or pivot table to allow me to pull out from here only those things. Okay, so what I do is I can select the top row if it's already formatted as a table, or I can select the whole table. okay, either or. And I can go to Insert. I can go to Pivot Table, okay, which will just show a pivot table, or I can go to Pivot Chart, Chart and Table. I'll do both of them at the same time, okay. We can do them one at a time, but I'll show you both. And so it asks us here, the data I've selected, yes, okay. I usually just leave that the way it is. A new worksheet, yeah, I'm going to put it on a new tab, okay, yes, okay. And so it generates this worksheet 2, which is a new tab of the data I'm about to input. And so this pivot table here and this pivot chart are all based on the pivot chart field that I'm going to build on this right side of my window here. And so we have a couple different things. We have our categories, our things here, right? Our column headings. We have filters, which we're not really going to deal with a whole lot. But then we have the axis category, and we have the series. And I can maybe... And so basically what this is this is our rows and columns, okay? And we can put in here rows and columns to determine what are the different pieces of information we represent. And then values, okay? And so what I'm going to do first is individual, maybe on my series. Okay, so across the top, my column is individuals. And then I'm going to do phase along the bottom there, and I can move this out of the way. And what I've done now is I have phases on the left by individuals along the top, okay? And then the data that's going to go inside here are my hours, okay? And those are the values. Okay, so I click hours and I pull it down here to values. Now that populates and shows me that Joe spent 2 hours in development time. Actually, 2 hours total. He only spent time in the development phase. Also, I see that I spent 171 hours during development, 58 during pilot, and 52 3/4 in steady state, with a total of 281 and change, right? And so now I'm able to see, based on the individual and my phase, what the different times that were spent, are. And I can show it graphically here as well. So these are all my development times, pilots, steady state. Of course, from what I see here is, wow, Tom spent the most time of anybody, and he spent it in the development phase. Okay, so that's a clear result that I see. I can see that tabularly here in a table form, right, by this value here for Tom, but it really jumps out at me in this graph. Okay, and so this is how I can build, and I can, I can move these around. I can, reverse that. So now I have individuals along the left, and I have the phases along the top, and that really, just changes a little bit, but slightly changes the graph, but tells the same story. It's just a reverse way of viewing it. I could say, okay, well, I don't care about hours. I want costs, right? I'll drag this, get rid of the cost, or the hours, and I'll go and I'll put cost in, right? So the bottom line, how much did it cost me? And then I can copy these and actually format those as costs, okay? So now I see as well that total cost of around $12,000, and I think probably Tom, yep, again, he is the outlier, right? He is costing me $10,000. Man, what is he doing with all his time? But he is our most expensive individual, right? Spending the most time, costing the most money, right? But we're able to, with this pivot table, pull out that information very quickly from this table, right, of multiple rows. That would be harder to do. And so here we have a very quick, easy interface. We could even do other things. We'd have, sub categories here where we see James as a teaching assistant, Joe as an admin staff, and maybe we orient that the other way around where we say first position and then individual, and we can say, all right, so our admin staff was this much, our instructor was this much, our lab staff was this much, and our teaching assistant was this much. Okay, and these are the different people that make up the teaching assistants or the instructors, and we can minimize these, right? So this allows us to drill down into our data very quickly and easily and sort it and organize it and filter it by all different ways. And we can show it graphically, we can show it with table form. We can also come in here and actually physically filter, just like before, and say to get rid of all the teaching assistant time and only show everything else, right? And so then we can come in here and only see that. So that's a pivot table. That's the functionality we have in pivot tables. Very, very powerful tool in Excel, especially when we have tables of data. It allows us to quickly and easily represent those as concise, consolidated tables, and even some charts and graphs here. And of course, it's all based on what we set up on this dial-up window here. And of course, the values, what we see, the numbers we see in the table, we can change those from sums. We could have them as counts. We could have them as average. So what's the average cost? Depending on your application, you may or may not, want to do averages. You might want to do totals. We could do max. We could do min, right? Product. For what we're doing, I think it makes the most sense to have the sum, right? What's the total amount? Okay, but you have some options there, and you have an ability to do your rows and your columns, right? And customize what you see and how you view it. Okay, hopefully that's been helpful. We've talked about goal seek, okay, and of course that's one variable at a time. We've talked about solver, that's multiple variables at a time, and then we've talked about pivot tables. I'll see you in class.